Hello everyone, welcome back to a new video. So in this video, we'll be solving some more questions related to arrays and vectors. So without further ado, let's get started. So the next question that we have here is to rotate an array. So we'll be given an integer array nums and we have to rotate the array to the right by k steps, where k is a non-negative integer. So let's have a look at the example. So here we have been given an array nums which is consisting of elements 1, 2, 3, 4, 5, 6 and 7, and we have to rotate the array to the right by three places. So as you can see, as we have to rotate the array to the right by three places, so the last three elements, which is 5, 6 and 7, are taken back to the left of the array, which is the starting of the array, and all the other elements, which is 1, 2, 3 and 4, are shifted towards the right by three places. So my resultant array would be 5, 6, 7, 1, 2, 3 and 4. So now you can see if I want to rotate the array towards the right by two places, and my array is consisting of elements -1, -100, 3 and 99. So as you can see, the elements 3 and 99 are taken back to the left of the array, which is rotated towards the right, and all the other elements are shifted towards the right by two places. So how can we solve this question? So let's try to observe something. Let's suppose I'm having an array which is consisting of elements 1, 2, 3, 4 and 5. If I want to rotate the array towards the right by one place, so my resultant array will be looking like my 5 will be at the starting of the array, and all the other elements, which is 1, 2, 3 and 4, will be shifted towards right by one place. So 1, 2, 3 and 4. So this is my resultant array when I want to rotate the array by one place. So now if you observe carefully, if I can store this 5 element in a temporary variable, and I can then shift all the other elements towards the right by one place. And after shifting all the other elements towards the right by one place, I can put the element 5 at the starting of the array. So my array would be shifted by one place. If I want to shift the array towards right by two place, then what I can do? So now I can store the elements 4 and 5 in my temporary storage, and I can shift all the other elements towards the right by two places. And after shifting all the other elements towards the right by two places, I can put back the other elements at the starting of the array. So my resultant array will be looking like 4, 5, 1, 2, and 3. So I can always store the elements in my temporary storage, and I can shift all the other elements towards the right by k steps. So let's observe something. Now if I want to rotate this array by 5 steps, so how I can do this? So for rotating array towards the right by 5 places, so I can rotate each element towards the right by 5 steps. So my resultant array will be exactly similar to the array which is given to me. So my output will be exactly similar to the input array. Now, if I want to rotate the array towards the right by 6 steps, so my array, the output array would be looking like 5, 1, 2, 3, and 4. If you observe carefully, my output when I rotated the array by one step and my output when I rotated the array by 6 steps is exactly same. So can you infer something from this? So I can modify, or I can write this 6 as 5 plus 1. So whenever if you want to rotate the array by k steps, so if my k is my multiple of the size of the array, so my output array would be looking exactly same to the input array. So if I want to rotate the array, so my effective rotations would be given by k equals to k mod n, where my n is the size of the array. In case of 6, if I want to rotate the array, so my k would be k equal to 6 mod 5, which is nothing but 1. So the rotating array by 6 is exactly similar to rotating the array by one place. So I can effectively rotate the array by one place to get the exact same results. I'll need a temporary storage to store the elements. So let's declare a vector of integers named temp. to store the elements. So I'll have to store the last k elements into this temporary storage. So I'll start iterating from I equals to n minus 1. That is my last index. And I have to store the last k elements. So if I want to rotate the array by three places. So this is my n minus 1, which is the last position. This would be n minus 2, and this would be n minus 3. So, which is n minus k. So, I'll keep on iterating till my I is greater than or equals to n minus k, and I'll keep decrementing the I. So now I'll push every element into the temporary vector. So temp dot push back arr of I. After pushing the elements into the temporary storage, we have to shift all the other elements towards the right by k places. So for I equals to n minus k minus 1 till my I is greater than or equal to 0, and I'll keep on decrementing the I, and so I'll need to shift the elements towards the right by k places. So if currently my element is at the position I, so I need to shift it towards the right by k places. So arr of I plus k is equals to arr of I. So I'm shifting all the other elements towards the right. So now I have to put the elements from temporary storage back into the my array. So I'll start from the index I equals to. So how to calculate this index? So if in this array, if I'm rotating it by three places, so the 1 and 2 will be coming to the front. So 1 and 2 has been already shifted towards the right by two places. So this would be index number 4, this would be index number 3. And these places are empty as of now. So I need to start filling the elements right from the index 2. So which is nothing but the k minus 1th index. So for I equals to k minus 1 till I is greater than or equal to 0, and I minus minus, and I'll take an variable j for putting the elements from temporary storage back into the array. So arr of I equals to temp of j, and I'll increment the j by j plus plus. So this has put back the elements from the temp back into our original array. So this will be giving us the resultant array. So let's talk about the time complexity and the space complexity. So what will be the time complexity? So I'm putting the k elements into the temporary storage. So this will be taking us the big O of k for putting the elements into the temporary array. Now I'm shifting all the other elements towards the right by k places. So this will be taking us big O of n minus k. And now I'm putting back the elements from the temporary storage back to the original array. So this will be taking us big O of k. So overall time complexity will be big O of k plus big O of n minus k plus big O of k. So effectively it would be big O of n plus k. So what would be the space complexity? As I'm using a temporary storage to store the elements. So my space complexity would be big O of k, where k is the number of places by which I have to rotate the array towards the right. So this will be overall time and space complexity. So can we get rid of the extra space that we are using over here? So my answer is yes. So we can get rid of this extra space that is we are using over here. So that would be our optimal approach to solve this question. So let's have a look at that approach. So the optimal approach is based on some observation. So let's have a look at some observation. So let's suppose this is my array and I want to rotate this array towards the right by two places. So my output after rotating the array towards the right by two places will be looking like this. So if I now want to achieve this output, so if I reverse the last k elements, that is 5 and 6, and I reverse the remaining elements. So if my n is the size of the array, I reverse the k elements and then I'll reverse the remaining n minus k elements. So my array will be looking like 4, 3, 2, 1 and 6 and 5. So I have reversed the k elements and I also reversed the remaining n minus k elements. So if I now reverse the whole array, so my array will be looking like 5, 6, 1, 2, 3 and 4, which is nothing but our output array after rotating the array towards the right by 2 places. So I can easily get my output array by firstly reversing the last k elements, and after reversing the remaining n minus k elements, and finally reversing the complete array. So I need to reverse the last k elements. So reverse from n minus k till the n. So I'll reverse the array from the n minus k till the n. So here this n is not included, so it will reverse the array till the n minus 1th index. And now I need to reverse this remaining element. So my starting index would be 0 and my last index would be n minus k minus 1. So I'll reverse the array from 0 to n minus k. So here this n minus k is representing the reversal of the array till the index n minus k minus 1. And finally, I'll reverse the complete array. So reverse from 0 till index n. So that was about it. So let's talk about the time complexity and the space complexity. So here we are reversing the last k element. So this will be taking us the big of k. Now I'm reversing the remaining elements. So this will be taking me big O of n minus k. And now I'm reversing the whole array. So this will be taking me big O of n. So overall time complexity will be big O of 2n. Here the time complexity is more as compared to the previous approach, but we have improved our space complexity. So here we are not using any extra space. So my space complexity will be big O of n. So let's try to code this question on the editor. So firstly, we need to update the value of k. So I'll update the value of k as k equals to k mod our size of the array. So that will be denoted by the num dot size. Then I need to reverse the last k element. So that would be reverse from the num dot n minus k till the num dot n. So this will reverse the last k element. Now I'll need to reverse the remaining element. So I'll reverse from nums dot begin till the nums dot end minus k. So this will reverse the remaining element, and finally I'll reverse all the elements. So that will be from nums dot begin till the nums dot end. So this will rotate our array to the right by k places. So let's try to run this on the test cases. So as you can see, it is successfully passed all the test cases. So let's now try to submit this. Yeah, indeed, it is successfully submitted.